Hi everybody and welcome to another UH Studio Architectural Design podcast. In this episode, I'm very excited to have Wassim Jabi as a guest. Wassim Jabi is a professor and the chair of computational methods in architecture at Cardiff University, and he's most well known as the leading force behind a software package called Topologic. Topologic is an open source tool which may be the next frontier beyond BIM in a more simplistic manner to get a lot of information out of as minimal amount of geometry as possible. Now do know that I did have some audio issues when recording this on my side. Basically, my mic volume was a little bit too high, so apologies in advance if you hear a little bit of audio clipping. So let's hear now from Wasim and his introduction and background in regards to his architectural education and teaching experience.
Yes, so basically, I did my undergraduate degree at the American University of Beirut, long time ago, and then I immigrated to the US, did my master's at the University of Michigan. And while there, I got introduced to a lot of courses or modules, as we call them here, regarding computer-aided design and how to use tools and how to build tools. And that kind of sparked my interest in this whole area. And I decided to stay on at the University of Michigan to do my PhD. So I did my PhD under the supervision of Professor Harold Borken. And I did a minor in artificial intelligence, also at Michigan. My dissertation was about computer-supported collaborative work. How do you support distributed teams working together? And that started my journey, yes, definitely. And then my first job right out of the PhD program was at the State University of New York in Buffalo, where I taught as an assistant professor for a few years, and then moved to the New Jersey Institute of Technology, where I also taught for a few years there. And then we moved to Cardiff University in Wales in the United Kingdom. And that's where I've been here since 2008.
2008.
Yeah.
Wow, okay, great. So
Yeah.
quite a while.
Yes, yes,
So that's your home pretty much now, isn't it?
yes, exactly. We like it here. I think we've done well. I published a book in 2013 while I was here called Parametric. Parametric was it? Oh gosh, forget it. It's been a long time.
No, tell us about the book, Parametric Architecture.
Yeah, it's Parametric Design for Architecture. It's a book that kind of tries to a little bit reveal the kind of almost like mysterious art of doing parametric design for students. It's because a lot of them see kind of amazing results, but they don't always understand the process behind it. So I decided to write a book that is, explains the concepts behind it, but also gives them very specific tutorials on how to achieve certain geometric patterns.
Is that with Grasshopper or with some other software, or
No,
just more?
that was the point of it. Is that I did not want to use pre-made tools that just simply kind of give you things ready-made in a way, because that for learning. It's a little bit difficult to understand what's going on behind the scenes. So it's really all based on revealing the actual programming, the actual scripting behind these patterns, in order for students to learn what it takes to create these tools. And this is something that I'm doing also in my MSc. So right now I am directing an MSc in computational methods in architecture. And rather than focusing on tools like Dynamo or Grasshopper, which I feel a lot of students that are coming into this MSc already know, we actually teach them how to build these tools using Python. So we're going behind the scenes and really going to a kind of a deeper level of algorithmic thinking and parametric modeling.
It sounds like you're quite at the forefront of computational and parametric design then, and maybe teaching the next generation of students.
Yeah, I think so. And of course, you mentioned Topologic. Topologic has become now almost like a cornerstone of that program, that MSc. So we obviously Topologic is open source, so the students can take a look at the code, can understand it, and we we exercise it. We use it to kind of create all sorts of solutions.
So I know about Topologic for quite a while, from the OSARC forums and your constant wonderful posting on all the social media
Yes.
out there around it. But it took me a very long time to wrap my head around it. And in fact, I still don't think I quite get it. But I did read an article in AEC magazine
Yes.
where they had an interview with you, which I thought was maybe the first time that I completely grasped what it exactly it is. So for the audience that may not be so familiar with Topologic, is there a way for you to summarize it in a couple of sentences?
It is always a challenge. It is definitely a challenge because Topologic is very, very different from uh, the way kind of BIM software has developed so far. In a way, it is kind of not anti-BIM, but it's kind of like almost like it takes an opposite direction to BIM. So the best way to explain it is that, and I have, first of all, before I say anything about Topologic, I have to give credit to Professor Robert Aish, who started this whole thing back in 2013, 2014, and he talked about this concept called non-manifold topology. And I met him. We became friends. We became colleagues. We submitted a grant together to the Livermore Trust that funded us for £300,000 for 3 years, and that's where Topologic came from. So he really is owed a lot of credit for talking about this issue long, long time before I knew what non-manifold topology is.
And is that non-manifold topology different than the kind of non-manifold topology that's being talked about for, let's say, 3D printing models, or is it the
Well,
same concept?
different in the sense that non-manifold topology, when it's talk about 3D printing, is considered a mistake that you need to correct. This is about
Yes.
edges that are open, things that are not actual, like solids, internal faces that shouldn't be there, that kind of can ruin the 3D printing process. What we
Mm-hmm.
have done is we have looked at the advantages of non-manifold topology, and we said we can use that to represent space. So non-manifold topology allows you to represent a building, just as an example, as a outside envelope with internal subdivisions that represent the spaces inside that building. Those internal subdivisions are usually zero thickness, and the outside envelope is also zero thickness. So you are thinking in pure spatial terms rather than say, I'm going to build my building out of doors and windows and floor slabs and roofs. You can do that, but what happens is that the space is the kind of like the negative, non-existing entity in your model. Like if you look at a BIM model and you ask the BIM model, so what do you have in you? It will tell you, I have X amount of walls, doors, windows, floor slabs, but it doesn't usually tell you, I have these spaces that are connected in a certain way. There is no design intent built into it. You can always, of course, in BIM model, try to derive the spaces out and create rooms and spaces, etc. And Revit and BIM can do such things. But the topology of them, meaning how they are connected, is not always present. And you have to do a lot of ad hoc algorithms to retrieve that topology. So I'll give you a very simple example from Revit.
It sounds actually a little bit like, many times, especially in more complex projects, we work on in Rhino, right, to
Yeah.
generate a concept, or myself in Blender, but a lot of my colleagues in Rhino.
Yep.
And we start with very simple layout, let's say, of like a massing. The massing consists of just the external envelope. Then we insert some floors in there, and then we have like we can tell like the surface area and the overall area of the building envelope of that's being encompassed. But we don't go, and we have to do like many iterations until we get like a complex shape, right?
Yeah.
With the right mixture of areas and all the other elements that go into architecture design, like stairs, distances, views, and so on. And in those cases, we work as much as possible with the simplest possible geometry so we can adjust it very easily. But at some point, right, you know how the process works, we have to take that geometry and then we usually we build it from scratch. If it's angled wall or something like that, we do it in Grasshopper with everything then going into Revit. And like you were saying, we start creating walls and different spaces. But we do have a spatial diagram in a sense,
Yes.
which is that initial model. So is Topologic kind of thinking along the same lines? Is the concept of Topologic something similar?
Very, very similar to that, only that
Okay.
the spatial diagram is a topologically and informationally rich entity. So that rather than simply drag rectangles and boxes and just put them in an assembly, and it's not guaranteed that they know about each other, Topologic always ensures that your assembly is fully topologically connected so that you can tell that this room is next to this other room, this room is next to the corridor, or to find, for example, the shortest distance from a single office to the fire escape. So all of these analyses that you should be doing early on in the design process become available to you, because the kind of conceptual model that you are creating is very intelligent. It has a lot of information embedded into it. And Topologic does that behind the scenes, so that anything that you are creating, behind the scenes, it is represented as a graph. Graph meaning it is made out of nodes and edges that connect those nodes. So anything that shares a wall, for example, is connected. So in Topologic, you can, for example, ask a wall, which is like a single surface, what are the two rooms that use you? So it will immediately tell you, I have a room A on one side and the room B on the other side. And then you can ask those rooms, so what are you? And it will tell you, oh, I'm an office. And the other room might tell you, oh, I'm a conference room. Having that information allows you to take decisions regarding that wall. So a wall that is between an office and a conference room might need additional sound insulation, for example, or different materials. It just simply, everything in there is represented as a graph, and therefore we can use graph theory to traverse it, to mine that information, and take early design decisions on a very lightweight model, geometrically lightweight, but topologically and informationally rigorous. It has a lot of information in it.
So what is the typical architectural design process for a designer using Topologic?
Yeah. So what we are advocating, and it's something that Robert and I thought about really deeply, and we proposed that to the Lead from Trust when we wrote our research proposal. We would like nothing less than to change how the industry does its work. This was our ambition, in the sense that we know and we predicted that architects are going to say, we have these very complex BIM models. Could you please transform them into topologic models so that we can do different types of analyses, like energy analysis or structural analysis or fire route analysis? We are advocating that you should start with conceptual models, very much like what you described, but these conceptual models are very rich. And then you allow software through AI methods, rule-based methods, shape grammars. There are many, many routes that software can take to convert your conceptual model into fully fledged BIM models.
And are those methods incorporated within Topologic, or would that be typically an extra step?
That would be an extra piece of software, but we have several examples of people who have taken Topologic and converted it into really rich BIM models. One example is Homemaker by Bruno Possel, which you probably know from the OS Arch community. He has built a software called Homemaker that is built around Topologic as a first step. So you build a Topologic model, very simple, like a cube, and you slice it with surfaces. And then he takes that, and with one click, it becomes what we call a cell complex, so very topologically connected. And then based on rules, it immediately converts it into a fully ISO standard IFC file using native IFC methods with all the windows and the doors and the details and the cornices. Everything is embedded in there, including a structural model, including an energy model, all embedded to a very, very high standard. And that is all done almost without human intervention. Now, if you want to change the shape, rather than changing walls and windows one by one, which is very complex and can lead to a lot of errors, you go back to that conceptual model, change it, and with one click, it does the translation again and creates a new updated model for you, following very strict rules.
That's very interesting. Yeah, I know about Homemaker. I'm following the thread on OSR quite a bit myself. I did try a long time ago to try to use it, but I remember at that point the installation was a bit more complex with some additional Python libraries. I think last I checked, it's just a simple add-on.
It is.
So it sounds very much like it's time to give it another try.
No, absolutely. Yeah.
So about that kind of setup, to continue with the conversation that we started with the typical optimal design for a designer that might wish to utilize Topologic.
Yeah.
So we said we start with a conceptual model, then that conceptual model is passed through a software like Homemaker, and so there is a plugin for Grasshopper, but that's Topologic pure, right? And do you know within the Grasshopper world if anybody has taken Topologic and incorporated it into their kind of similar plugins like Homemaker?
So basically, when we are in the Grasshopper and Dynamo worlds, you have a plugin for Topologic. I have to say it is a bit now out of date. So we need to. Mm-hmm. There's a new kind of reincarnation of Topologic called Topologic Pi, which runs in a Python environment, pure Python environment. It runs in Jupyter notebooks. You can also embed it in any system you want. You can embed it back in Blender or in Dynamo, if you use custom Python nodes. Grasshopper, because it's Python 3, you can do it in Grasshopper, but I think it needs a bit of attention to how it's done. But if you are in Dynamo and Grasshopper, we have examples of both from industry and from my students that, and also, by the way, from one really, really good PhD, Miguel, who took Topologic Grasshopper, and he wrote his whole PhD on it, converted it very intelligently to Revit models. Now, he's saying that conversion to Revit model is actually the kind of the easiest step that he had in his research. It was all about kind of the information and reflecting on both the geometry, the topology, and the information in there to kind of understand what that building should be. In terms of if you're using Topologic in Dynamo, I have worked with a really brilliant Syrian architect. His name is Ahmed Al-Tahlawi. He's in Germany. He works with ePro Consult. And he has written custom Dynamo scripts for his company that take test fit models. I don't know if you know testfit.io. They do kind of test fits. So we took test fit models. We converted them into topologic models so that we know what these walls are separating, because we needed to make decisions on these walls. Is it an external wall, internal wall, what kind of wall? And then we meaning he mainly, converted it to a very, very competent Revit model that is, can be used for design development.
Okay, so and just for the audience, if you don't know TestFit, it's a separate piece of software used for conceptual design, mostly for feasibility studies, for both architects, but also for developers and investors. And it's quite a neat piece of software because it kind of automates the process of finding out not the design part so much, but the feasibility part. The design part is still left to architects afterwards, who come a little bit later in the process. But just understanding whether a site has the potential to be developed and whether somebody should invest the money into acquiring that site. And that's what TestFit is used for quite a bit.
Yeah.
Okay, right. So going back to that whole idea then. So I'm a designer, architecture designer. I have my conceptual model. I am using I would be using Homemaker because I use Blender, and I hope more people start using it. But there are alternative paths, as we're hearing now from some of your students and from the industry as well. I don't know how packaged those are just yet
Not
in regards to, are there like scripts or something that people can grab from somewhere to
so,
incorporate?
so the translation to Revit, for example, not yet. No, we'll
Okay.
have to hunt for it. We will try to make that. I have to talk to Ahmed, and because it's coming from industry, so it might not be as available. But we'll try to make translators. We are very aware that uh, topologic models need to be translated into thickened BIM models, as we call it. Right now, the most sophisticated solution is in Blender through Homemaker to IFC, and
Mm-hmm.
I think that is the future. I believe open BIM and native IFC authoring, as Dion Moult has always said, is the way to do it. And that's where I put a lot of the effort of working with Bruno Possel, helping him with the topologic side, and he is obviously an expert in kind of exercising the IFC API to do it. Once you have that IFC file, kind of the world is your oyster. You can do whatever you want with it. Now, the
Yeah.
connection to Revit, I think we need more work and we need more resources to make sure that we have an open source method to create Revit models. But as you know, Revit does not have kind of an offline API that is open and we can just use. Like you have to have a Revit license and you have to work within the Revit environment. But we have several people who have, for example, used PyRevit as a plugin in Revit in order to kind of connect Topologic to Revit. Uh, in our case, we use Dynamo because Dynamo talks to Revit as well. But all of that is not an open source method, and you need a Revit license and you need Revit software to do this work.
Yeah. Okay. It sounds fascinating from the standpoint of automation. Uh, and I imagine that there has to be some manual post processing,
One more
because
time, please. What?
I imagine there has to be some sort of manual post
Ah,
processing. Because let's say typically what happens is, we sketch, let's say, a residential building, because residential buildings, they might be the most time intensive, to figure out the footprint, the right mix, the right ratio of 1 bedroom, 2 bedroom, 3 bedroom flats, and so on. And so we have a mix that we quite like. We work out a couple of typical floor plans. We would do the concept model for that. We pass it through Topologic and, let's say, Homemaker to develop the BIM model of that. But then at some point, a designer or the client says, okay, for these kinds of flats, can we move the doors a little bit to the left or the right? Or, can we reorient, or can we move like some of these windows a little bit? Would that be the kind of edits that people would have to redo the whole like topologic cycle again? Or would it be something that, okay, fine, you're in whatever BIM modeling software that you're using, and go ahead and just adjust those few things in there?
so the parametric designer in me says no, you shouldn't kind of change things at the end because that breaks that kind of parametric connection. You should go back and change it in the conceptual model. If your translation software is smart enough and rigorous enough, it should create very ready to go BIM models. They should all be correct. And what I have seen, especially on the IFC side and the Revit side, is that these models really don't need a lot of manual intervention. Now, obviously,
Mm-hmm.
these are still early days, and with a robust AI infused, AI dependent, software, you could really take a very simple model and convert it into a very sophisticated BIM model. You should also look at, for example, what Hyper has talked about recently, where are using command prompts to, and something like, I don't know if they're using ChatGPT. I think they probably are, but basically converting a linguistic description into a full BIM model. Now, this is obviously just a proof of concept for them at this point, but you could see kind of the trajectory of where that is going. I've always said for many, many years, software is much better at populating BIM models than humans because they follow rules and they can look at all the little details and make sure everything is satisfied. And humans don't have sometimes the interest or capacity to do that. So if I'm going to fill a conference room with chairs or a lecture theater with chairs, I'd much rather do it through software than me sitting boringly kind of putting these seats in their position.
It's funny you mentioned that because that's the whole reason I became a parametric designer or made it so much a part of what I do, because I had to, I was working on an auditorium at AJ Associates over 10 years ago. And, you know, the era, we do have a very kind of strong computational background,
right?
But it's more research based instead of practice based. But I knew the tools and I knew the availability. So we had this auditorium that the shape was changing all the time. And so, you know, it's exactly as you say, you know, I had to manually, you know, get the curve from the center stage and go backwards and position it. I was like, it's got to be a better way, faster way. Of course, the faster way initially is always spending a lot more time up front and learning over laborious weekends and late nights. But then, you know, it worked in the end. You know, I was quite satisfied with it. So is there, on that respect, is there also a learning curve of using Topologic? Or if it sounds like at this point, pure Topologic, the ideal user is not a designer, but maybe some kind of developer that incorporates it into their plugin or add-on, or a parametric computational designer perhaps who can assist with utilizing Topologic for accessing more data from the model.
So to answer your first question, yes, of course there is a learning curve, and we have to do a better job of documentation and tutorials. Right, so far Topologic because it grew out of an academic setting, it's very much like academic software, and you find YouTube videos here, you find web pages there, and kind of API documentation in another place. All of that we are hoping to bring together this year because we just got a bit of funding to what is called to increase the impact of Topologic. So we're going to hire a research assistant. We're actually looking right now. If anybody's interested, please apply. And this person is going to help us bundle all of this together, make very, very slick, very accessible documentation and a set of tutorials, both text tutorials like in Jupyter Notebook, as well as video tutorials. I mean, you mentioned developer and designer and maybe computational designer. I see this kind of starting to merge. I don't see, for example, in architectural firms, people who are just purely developers. I think that it's becoming more spread out, where an architect can become a computational designer, and then after a while, they start learning how to script and build their own tools. And that is the kind of person that has multiple skills. That is the exact person that would be using Topologic. As an example, I mean, just to give you kind of a profile, Ahmed Al-Tahlawi, who I mentioned, who works with ePro Consult, he was a pure architect. I mean, he was able to use Dynamo at a certain level, but he had a very methodic mind, or he has a very methodic mind, and was able to understand the power of Topologic. Once he has done that, he was able to use the Dynamo nodes in a very sophisticated way and build very sophisticated workflows. But now he's moving into the new stage where he is teaching himself Python and is now able to write custom Python nodes and drive Topologic in a much more efficient, much more compact way through Python scripting. So it's that kind of journey where you start as an architect or designer interested in these types of computational methods. You start using these visual tools, but you quickly understand they have a certain limitation and they take up a lot of real estate and they become very complex. and very hard to read. And then you start being more efficient by learning about, let's say, whatever scripting language it is, whether it's C++ or whether it's Python, whatever you are using, and start writing software in a much more algorithmic way, in a much more compact way.
Right. Okay. Yeah. Interesting. Because yeah, there is a generational divide, let's say, within the architecture industry of um, young students, fresh young graduates. They know a bit of computational design, and depending on where they're coming from, they know different things. Clearly, like when I was working in London, uh, working with a lot of part ones and part twos that I was taking on to our team, there was some that they only knew SketchUp, they didn't even know Revit, and then we had the other extreme from Bartlett students that actually knew Houdini,
Yeah.
Which has its own computational workflow, which is not that used in practice just yet, but if you have that kind of analytical thinking, it's actually very applicable to doing Grasshopper scripts, Python, or Topologic.
Yeah, absolutely. I mean, this is kind of what I see in the students in our MSc Computational Methods in Architecture, that they come to us knowing a bit of Grasshopper or maybe a bit of Dynamo. Almost everybody now knows Revit coming in, so we don't even need to teach it. But what they are looking for is the ability to understand the kind of the concepts behind computational design, and how can they kind of yield it, make it yield to their own will, basically, like making it do exactly what they wanted to do. Because that's kind of the biggest complaint, is that, like, I know how to put these nodes together, but I'm getting a slightly wrong result. And so how do I do this? Sometimes it's a lack of understanding of the nodes and what they do, but sometimes it's just a limitation or a built-in assumption that the developer of the node has put in, but you don't have any control over it. So you will have to kind of go all the way around. So what I start teaching them is how you can, if something is a dead end, how you can go around it and do your own thing, how you can write your own Python script. And I demystify that process so that they feel comfortable writing their own tools. So we are graduating a generation of tool builders rather than tool users. And I think you will see that shift. It's an ongoing shift, I think, in industry, where the architects and designers that firms are hiring are able to create their own tools. If they don't have them ready-made, they can make their own.
Yeah, it's a very interesting aspect that I'm fascinated by, and I do have my own suggestions of people that wish to learn how to do it. You have to use it on a live project. You have to force yourself and like risk everything, and that's the best way to learn it because you have no choice.
Absolutely, 100%. I always tell them, whenever you're trying to learn something, use it on a kind of a real problem of some sort, solve something, rather than just use the tutorial and learn it in a very abstract way, because that does not exercise the limitations and kind of the potential of it. It does just the standard road. But what you want to do is do something that will challenge it so that you can understand what it can and cannot do.
Exactly. Yeah. Right. Okay. So, Topologic. How long have you been developing Topologic for?
So the initial grant we got was in 2016, and it was 3 years until 2019. That's when we published the kind of the first version. And just looking back at 2019 version, it was very basic. It did a lot of amazing things in terms of topology and regular and irregular Boolean operations, but we did just the basics. And we were very happy with that. We published that. After 2019, the team dissolved. Robert H. went on to other things. The team went on to other things. I stayed with Topologic and decided to champion it and move it forward, looking for the next funding round, or looking for it to kind of be sustainable. What I quickly decided to do is to make it as open source as possible and to make it free to use so that more people use it. And what I found out is that people are not going to be interested in recompiling C++ code. They're not going to bother with that. And so if they want to adapt it or change it, they're not going to be doing that. So I decided to put a layer of Python on top of it so that kind of amateur or half amateur developers and architects can deal with just the Python layer. And once I did that, I found out that, I can very quickly start adding features that are not in the code, but they're supported by the lower code. And then all these features are now available, and that is what is making Topologic and Topologic Pi, which is that Python layer, a lot more powerful than the original version. So it's been developing consistently from 2019 till now. And right now, it's a very, very extensive library. It can do a lot of things.
So it's quite young in regards to software. So it has which is great because that means we hear so much about Topologic already that we're only going to hear so much more about it.
Yeah, I think it has. I hope it has a bright future. We are looking at ways to make it more sustainable and increase the people who are using it. And kind of stay tuned. There are a few things that we are trying to do to have impact on industry. That our main goal in academia and behind the Topologic project is not so much to monetize it. We do not want to monetize it. We don't care about that. We want it to be free and open source forever. But we want to have an impact on industry. We really feel the industry is suffering from the current workflows and unfortunately, from these large software companies that are very slow to adapt, very slow to kind of respond to the demands of our industry. So we want to show them a different way, and that's what I'm doing.
I always thought that we have to rise up, as the architecture industry, both from the academic and practice sides, and write our own software. Because, like you said, those big companies, they're not looking out for our interests, they're looking out for their own interests. Sometimes our interests and their interests meet, but sometimes they don't. They're looking out for their shareholders and so on, and we're looking out, okay, how can we make our job easier? So completely agree with that. And yeah, it sounds like Topologic in the future might be an essential part of reclaiming some of those rights. Because back in the day, everybody used to draft on paper and pencil. It's not like somebody would go and steal the paper from you, right? It was your paper, maybe your company's paper, fine, but you could, if you sketch on it, it stays with you, with the design, with the form, with the architecture. Whereas now things with subscription software, they're not quite that straightforward anymore. And so besides architectural design uses, are there any other kinds of uses for Topologic?
So yes, one of the early users of Topologic was an MEP engineer, because they wanted to route pipes and HVAC things, ducts, and kind of analyze it. And because Topologic is all about graphs and topologies and how things are connected, it is very compatible with that. Another, of course, early use of Topologic was in energy analysis, and energy analysis is not usually is done by engineers, actually, not architects. So we've had Bureau Happold be very interested in Topologic, and they included it in their BHOM, their BOM model. And then one person who was with Bureau Happold and left, Mikhail Degunziak, he went and worked with Holia, another company, and he invented something called SAM 2.0. And that also incorporates Topologic in it in order to clean and establish relationships between spaces, because you need that for energy analysis. So it is used a lot in these types of rationalizing and adding information to analytical models that are needed for structural analysis or for thermal analysis or ducting and routing and stuff like that.
So usually engineers come in a little bit later, right? Once the design is fairly well established. So I imagine they probably work backwards from Revit models. Is that there? Do you know
Yes,
what their workflows are like?
yeah, absolutely. They work backwards from Revit models usually. But the good thing about these Revit models for MEP, and I'm not an engineer, I don't know anything about it. But what I have noticed is that they have very strict center lines and location points that allows you to step back into something that represents a network, a graph. And that
Yes.
is very compatible with Topologic. So Topologic doesn't need to know the exact faceting of some pipe or whatever it is. It might need to know the diameter or the capacity or the length and what it connects in order to do a lot of useful analytical work.
And is it also useful for things like automatic spatial planning? So going back to the
Ah,
architecture side, I'm always
sure.
thinking about architecture, but if you have a graph, basically it's a relational graph. If we can
Yes.
summarize topologic in one sentence, would that be it?
Yeah, I mean, yeah, exactly. In terms of kind of spatial generative design, that we have a lot of examples of that from our students, from the MSc students. So they have,
Mm.
and as well as PhD level. So they are using it to using generative adversarial networks, for example. And now we probably will move to like large language models and try to test that as well. But basically, they are trying to generate from a graph, trying to generate a what we call a believable architectural floor plan. And so we have one example, really, really good example of using machine learning to learn from previous precedents about what makes a good, let's say, school floor plan, and then
Mm-hmm.
Topologic creates a new one, and then tests that against it and classifies it and tells you whether it fits within the canon of school buildings. You know, whether it is like a proper school building or not.
So like Chat GPT for architecture.
Without right now, I don't want to over-claim it. Without the language model, we don't have that. That work was done a couple of years ago, so we were still in the world of machine learning, of GANs, generative adversarial networks, that kind of work. But I believe most probably I'm going to get a new student next year that's going to tell me I want to use ChatGPT or GPT-4 to kind of convert a description of a building into a full topologic model.
Is your students' work publicly available somewhere where people can look at it?
I don't ask them to do it. I sometimes tweet about it if it is necessary, or they put it on LinkedIn if they have a profile. But we will look into that. Yeah, I mean everything. My philosophy is everything we do is open source. Is everything is available. Like for example, we invite guest lecturers to come and give us lectures at the WSA at the World School of Architecture. Those lectures in my program are always recorded, they're always put on YouTube, and they're always made available to everybody, and the public can attend live. So I never try to close everything. As much as that possible, I open source everything I do.
That's great, yeah. And most universities, thankfully, these days operate in
Yes.
similar realms, especially when it comes to having outside keynote speakers and
Yeah.
try to publicize it as much as possible. So it sounds like at this point there is no maybe like a university website, web page for your modules, for your units, for your students where they.
Yeah, not in an organized way, but our program is fairly new. We're on our I
Mhm.
think fourth year now. So, but that's a really good suggestion. I will look at creating kind of a web section where we can share these these dissertations basically and all the code behind them.
Yeah, I'll give away one of my secret sources for inspiration. It's actually the AA's website because the AA is excellent at archival. So you can go back and look at whatever units are done. And I did my postgraduate there, but the diploma students at the AA, their quality of hand drawing is phenomenal. Not only hand drawing, just drawing of images. So if I'm looking at what the latest trends are in regards to design representation, I actually look at the AA students' work because they do an outstanding job.
Oh, yes, I fully agree. I'm very familiar with the AA because I used to externally examine the MTech program with my.
Oh, okay.
Yes,
Yeah, our neighbors.
yes, exactly.
So, what is next for Topologic? Do you have like a framework or a, a plan of what you would like it to invest or who you would like to collaborate with from the industry to use it?
Sure. Yes. So, I mean, there are. I have a very long wish list, obviously. Some of it is about housekeeping and making sure the infrastructure is sustainable for the long term. And that means right now, what happened is that Topologic Pi, which you can install from pip install Topologic Pi very quickly, and just runs independently, like you can run it in a Jupyter notebook or from a Python command prompt, even like it just runs by itself. That has the most up-to-date code. We need to migrate that latest version of the code back to Blender and Spatial within Blender, which is a kind of a Grasshopper clone or kind of alternative to Grasshopper within Blender. So we need to make that code available there. If we get more resources, the next thing would be to update the Topologic Grasshopper and Topologic Dynamo plugins to use the new code because there have been a lot of bug fixes and new features. So we need to bring that up. So these are kind of the three things that we need to get done: Blender, Grasshopper, and Dynamo, to make them all compatible with the same architecture underneath. Right now, they're not exactly the same. But beyond that, and I've been having discussions. I don't want to talk about them too much because nothing has come, has not become formal yet. But all I can tell you is that there are two or three companies that are talking to us, and we are trying to explore how Topologic can be incorporated in their products. I'll tell you more once I can tell you more, but right now it's really very early days.
And I imagine those companies are probably engineering companies or the software they, but that's for the public to guess.
I mean, it's really different disciplines, but they all can benefit from having their models imbued with intelligence of how things are connected, and what's the information embedded in these models. For that to happen, we need to finalize the licensing scheme, so that we offer them what is called an LGPL license, so that they can incorporate Topologic within their product. Usually it's closed source. That's why it's a difficult thing, because Topologic is under an AGPL license, which forbids incorporating it in closed source software. If your company is creating open source software, you can actually take Topologic, embed it in your software, sell it, and you don't owe UCL or Cardiff University any money. I mean, that's the kind of philosophy behind it, is that it's available for you to use as long as you follow the same open source philosophy as we are advocating. It's free to use. As an engineering company or architectural company, if you want to use it internally, it's completely free to use. You don't have to worry about anything. You can install it on 1,000 seats, and it's yours forever. You can use, it's your software. You can use it, you can customize it, do whatever you want to do with it, and you don't owe anybody anything.
Okay, so you mentioned UCL. Is it because Robert was from UCL, or?
Yeah. So basically, UCL and Cardiff University collaborated for the original Liverpool Trust. So the intellectual property is owned equally between UCL and Cardiff University. We are right now working with them on creating a new agreement that will allow Cardiff University to manage the licensing, because Robert, I believe he is retired or semi-retired right now. So basically, Cardiff University is taking the lead on Topologic with me, of
Mm-hmm.
course, and we're trying to see how we can manage it for the future.
So open source, but depending on the license, it can sometimes be incorporated into closed source software, but sometimes it's a bit tricky, basically.
Yes, in order for somebody to incorporate it in a closed source software, they need to talk to our lawyers to get an LGPL license, which will cost money.
Mm-hmm.
I mean, I think that is what Cardiff University and UCL are looking for. Obviously, if they want to if you want to monetize it, so you only have to pay money if you are following a closed source uh, pathway and you are uh, trying to sell it, trying to incorporate it in your model. We basically wanted to prevent a large company, in the US, for example, just simply taking Topologic and putting it in their software and announcing new features and selling thousands of seats. Obviously,
Yeah.
that cannot happen. We should not let that happen. But if your software is open source and you would like to distribute it and you want to include Topologic in it, by all means, you're free to do so. I mean, Homemaker is the same, Blender BIM is the same. They all have used Topologic in there, for example. Sorry, not Blender BIM. Homemaker did, and they distribute it, but they don't charge money for it. It's open source and free.
Yeah. It's great. I mean, I'm a big believer of open source myself, right? So
Same.
I believe Blender, open source tools are the future. I've had conversations with Dion on the subject about it. He gives a different perspective also from client operators and how important it is for them to keep having access to their data, after the project has been completed, in case they need to reference something or look into something. So there's definitely huge advantages of open source all the way around. Unfortunately, from the architecture design perspective, we're a few steps behind that, and it might be because architecture software alternatives to Revit are perhaps not developing at any pace to sufficiently allow companies to utilize these alternatives
Yeah.
within a very fast-paced, often chaotic workflows.
I mean, I partially agree with that. I think you're right. I don't think you can, right now, for an architectural firm, they cannot just simply abandon Revit and use something else. We're not there yet.
Yeah.
I think we're getting there. But my argument, and what I've seen done at ePro Consult, is that they use open source software as a parallel road. And it is almost like a secret weapon for them. So they can create really, really a lot of value through using open source software. At any point, the risk is very, very low because the data is yours, is available, and can be translated into something else. So at any point that you decide, I don't want to use that open source software, or the developer is gone and they're not developing it anymore, that data is yours and available and translatable. So you can just simply move on to something else. So there's very little risk in using open source software. And most open source software, which is available on GitHub, stays there forever. So as long as it's doing the job that it was designed to do, it will continue doing that. So it has a very long shelf life. And so that they found very quickly that the risk of using something like Topologic and Blender is very, very low, as well as on the other side, it created a lot of value for them. So why not use it? While they're still using Revit and all the other closed source software that they have.
Yeah, and if we imagine, like a phone, right, or anything else out, a software that's not architecture software, but like new online app software, always within their terms and agreements, they have references to the open source software that their software is using.
Yeah, exactly, exactly. People don't realize how much of the open source software is actually, is the foundation of this more sophisticated closed source software. Yes, they depend on it a lot.
Yeah. So Topologic, if I am a new user and I'm just getting started. I'm interested in all this. It sounds fantastic to me, right? I don't need to go into Revit. Let's say that's why context. So uh, it sounds like from our conversation, then the easiest way to get started is first off with Blender, right? And then with Homemaker.
Yeah, I
Is
mean,
that what you would?
I would.
If somebody's interested in it, how do they? What do they do?
I mean, I don't want to kind of give the impression that Topologic is only the gateway to BIM, because Topologic
Mm-hmm.
can do a lot of analysis on its own.
Yeah.
I almost never go to BIM. Like I do a lot of work in Topologic, a lot of analyses, a lot of visualizations while staying within the Topologic world. I don't need to translate it into BIM components. So you're right that perhaps using either Topologic in Dynamo or in Grasshopper or in Blender Sphere Chalk might be the first step to kind of drag and drop a few nodes if that's what you're interested in. What you are an expert in is kind of visual programming. That will probably be the easiest thing to get started. I would suggest that people look me up on YouTube and look at my channel. There is a playlist called Topologic Tutorials, I believe, and there is Topologic 101. Start from there and follow those tutorials and see how far you get. What I'm going to do next, very, very soon, is to start publishing Jupyter notebooks that are ready to go. So those you can run as small scripts, and I will annotate them and put some like nice um, uh, introductions to each one of them, what they do, and you will be able to download them and try them out. And then what I would suggest is you take those scripts and start customizing them and expanding them in order to increase your familiarity with what they are doing.
And what are a few good first kind of use cases that people should try out with Topologic? So you mentioned a lot of like analysis that you stay in pure Topologic. So is it like energy evaluation or structure or MEP? Is it like all the engineering things that we
all
talked
that
about?
all that is available. You will be able to do that, but I think that requires also a level of sophistication. The
Okay.
first thing I would ask for a complete beginner is you can create any kind of entity like a cell complex, and you can say with one node, with one kind of call, say, give me all your outside faces, give me all your inside faces, give me all your horizontal faces, give me all your bottom faces, top faces, and you can create a cost estimate, or you can create a kind of a report on these things, on what how many how what's the area of the outside of your building, what's the area of the inside. So these types of very, very simple calculations you can do very, very quickly. um, Recently I tweeted an example of what is called a visibility graph, and if you know about the work in the Bartlett on space syntax, uh, a visibility graph, it basically measures at every point in a floor plan, how visible are you? Like how can people see you, and can you see people?
Hmm.
And you can imagine, if you put it on a grid, you can measure that visibility at every point, and you can color code it and come up with a really nice color coded visualization, almost like a heat map of the most visible locations and the least visible locations. That could be very important, for example, for retail, for product placement. So you put the ones that you want to sell the most in the most visible places. It can also be important for urban design, to find out perhaps alleyways and places in your urban design that are very hidden, not very visible, and maybe dangerous. And therefore, you might change your design to make them more visible. So that kind of analysis that depends on how things are connected, what you can see from what point, is all very, very compatible with Topologic and very easy to do, actually.
Those are some excellent examples to look into and to think about. Now, is there an opportunity within Topologic to be iterative? In other words, can some of this data be used to adjust the design within Topologic, or is it more of an analysis tool that then
No,
needs to be plugged into some other ways?
no, Topologic is fully uh, based on programming concepts. So iteration, logic, kind of a fractal approach or a recursive approach is available as well. The full kind of logic that you would use in any kind of programming language is available, because you can obviously run it from within Python. So anything that's available to Python is available to Topologic. We have connected it to many third parties, third party libraries like NumPy and SciPy and machine learning and DGL and all sorts of things, and Plotly for visualization. And it's not a closed ecosystem. So if you get a new Python library that you would like to use, like let's say you want to get a GIS plugin of some sort, as long as it can run within your Python ecosystem, you can magnify and expand on the capabilities of Topologic. So yeah, it's really all available.
And it is also great that you mentioned urban design, because I always think that urban design, believe it or not, is one of the more difficult tasks to automate, because there are very specific rules that you have to follow. Roads, corners, what happens inside of blocks, how are blocks split up, what there's basically topological conditions, right, that are unique to each place. So have you seen any examples of people using it for urban design?
So, I mean, again, it's not. I haven't seen a lot of examples of it, but one
Yeah.
example was getting QGIS data. I believe there's a plugin in Blender. I think that person used it that way, and then by getting I honestly have not looked at it that closely, but it was basically he was building a graph that connected the buildings that are on the plot to the plot, and then the plot to the road, and then the road to other plots and other buildings. So, for example, even though two houses are not touching, right, they're like on different plots,
Mm-hmm.
it can tell that they are neighbors. Like, so if you're going to ask about your neighborhood and maybe get a median price or find out what's going on, kind of getting an inventory of what's going on, that graph is able to be kind of generated, and then you can ask it those questions like, find me, 2 steps away, or 2 stops away, what are the available urban inventory. So there are examples like that. We've done, I think currently, I'm trying to remember my students if they are doing anything with urban. I think I have one student who's taking satellite images and vectorizing them, and then building a topologic map out of them, so that they can understand what's going on in that sector, in that urban sector, and then evaluate it, like do an evaluation of it.
Mm-hmm. Right. So that sounds like it's also utilizing, let's say, some of the capabilities that ArcGIS uses, which is, you mentioned it already, grammars and so on.
Yeah, yeah, exactly. I mean, obviously, GIS systems are would be much more sophisticated and much more capable in that area. But if you want to do GIS light, or if you're a designer or an architect interested in this, but you don't want to dive deep into a piece of GIS software, you can still get some really useful information and analysis and insights without having to to do a full GIS. This is all. The nice thing about these things is that you can do them early in the design process, where you don't have to invest a lot of time, a lot of effort, a lot of money, and also expertise to get some useful insights. Once you have decided on the basic design, now it's time for design development. Obviously, you need to go back and do these analyses at a much deeper level.
Yeah. Well, it's been great talking to you. And I feel like I know a bit more about Topologic. So a couple of important things. So you mentioned YouTube. You have a tutorial list for people that are interested on working with Topologic. So what do they need to search for to find you?
Just search for my name, Wassim Jabi, on YouTube. You will find me, and then go to my channel, and you will find under this channel different playlists. One of them is called Topologic Tutorials. But just Google my name on YouTube.
And then you also mentioned Twitter, that you are quite active on Twitter and you show industry examples or student examples as well. And Twitter, I believe you're using Topologic there, right?
It's Topologic BIM, Topologic BIM, one word.
Yeah.
That is the best. That's the best resource to find out the latest. Because I post on it almost daily. Especially when there's something going on. But also, if you go back, you will find Python code snippets. You will find examples. You'll find little videos. So I think it's good to kind of see the history of Topologic and then find out specific things about it.
And then on osarc.org, then there's also a few
Yeah.
threads talking about Topologic and how it can be used also within other software, right? And those are fairly active, I believe, as
Exactly.
well.
Yes,
And
there
are
is a
there?
very, very long.
Yes.
Yeah, there's a very long thread on Topologic that it started with, are you interested in a talk about Topologic? I was offering to give them a talk, and from there on, it went on for pages and pages, and it's a lovely, almost like historical document of how Topologic has been kind of discussed and developed over now almost a year.
And are there any other resources that listeners should be aware
Yeah.
of?
Yes. So basically, topologic.app is the main
Mm-hmm.
website. But also, if you use pip, I don't know if people know what pip is. Pip is a way to archive and download software very easily. If you want to install Python software, you say pip install Topologic Pi. But that is saved on a website called pypi.org, pypi.org. And that, if you look for Topologic Pi there, it takes you to the documentation. So the Topologic, also if you Google Topologic Pi API documentation, 3 words, Topologic Pi API documentation, the first hit is the Topologic Pi documentation. And that is really very modern, very easy to access. And also you can, there's a little triangle, you can open it up and it expands the source code. So not only is it
Mm-hmm.
documentation that tells you what you should code, it actually shows you the Python code underneath. Oh, I lost your audio, Dimitar. I think you're muted. Yeah, here we go.
Now sorry about that. I don't know how I muted myself.
No.
I'm coughing a lot, so maybe that's why. So yes, so we got YouTube, Twitter, and then topologic.app, and then osarc.org, and
Yes.
also the pip
Yes. The
module.
Pi documentation website is very good.
Great. Anything else you would like to add?
No, I would just simply encourage your audience to download it, use it. Do not hesitate to contact me. I'm very open. If I can answer, I usually answer very, very quickly. Also, if you are a company and you are serious about Topologic and you want to deploy it at a certain point, I'm more than happy to give your team a talk and a workshop about it. I've done that many, many times. It's as I said, it's part of our academic mission to have industrial impact. So if you are in industry and would like to use it, go ahead and invite me. I'd love to give your team a workshop on it.
Thank you so much, Wasim. Pleasure talking to you and finding a bit more about Topologic's wonders. And I appreciate you investing your time to do something that benefits the whole industry as well.
Thank you, Dimitar, for inviting me. I really enjoyed it. Thanks again.
Cheers.
Cheers. Bye-bye.